Now, this question here, very similar because of the fact that, we're being told that we have 20 words in total. 12 of them are known, 8 are unknown. And so you're being asked that if there's 10 words on the test, what's the probability that at least 8 of those words are ones that the student already knows? With this information here, I know there's 10 words on the test. So I know that my sample space number, and I said probability here, it should really be number, not P of S, but N of S. N of S is the combination where N is 20, R is 10. So there's basically 184,756 different outcomes. I can pick 10 vocabulary words from the 20 in total to make up the test. What I want to do is figure out the probability that at least 8 of the words on the test are words that the student already knows. I'm going to let x represent the number of known words. I know the probability of x being greater than or equal to 8 is going to be the probability of x being 8, the probability of x being 9, plus the probability of x being 10. I calculate these probabilities. So for me to get 8 words on the test that that the student already knows, I'm going to do the combination of n being 12 and r being 8 to represent choosing 8 words from the list of those that he knows, and times the combination of n being 8 and r being 2 to represent the number of possible outcomes where I'm choosing 2 out of the 8 that he does not know. Then I do the same thing for 9, except now I'm going to have the combination where n is 12 and r is 9 times the combination where n is 8 and r is 1. And the last one, the combination of 12, 10, that's basically a circumstance where I'm taking because I'm saying that all 10 are from the group of 12 that I know or the student knows. So I'm going to choose 10 out of that 12 and divide that by my NS, and that's going to give me these numbers here. And so when I add those probabilities together, I get 0.08490. So the possibility or the probability that at least 8 of the words, 8 or more of the words that are on this test are going to be ones that the student already knows is about 8.4%. So not really a huge percentage, so it would be a good idea to learn the other words. So this last circumstance is quite different. In the previous ones, we had a defined group of a certain number that had certain characteristics, and that we were picking basically subsets of a smaller number from it. I don't have that here because I don't know how many how many are in each one of these groups. I do know 5 people are being picked, and we're looking for the probability of at least 2 of them having the characteristics that are named here. In A, the characteristic is that they have the same sign. It doesn't say which sign that is, but they have the same sign. And B, they're born under the sign of Aries. For both of these, we have to be aware that there are 12 signs of the zodiac, which we're told. When I look at the probability of at least 2 of them having the same sign, well, for me to say that any of them have the same sign, I have to have 2 or more people have the same sign. So if I think about it, the exact opposite of at least 2 of them having the same sign would be none of them having the same sign, or all the people's signs being different. So I can think about the probability of at least 2 with the same sign being equal to 1 minus the probability that all of them have different signs. Now, I'm not going to be able to use combinations here because I don't have group sizes that are of specific amount. I'm going to have to use basic logic on this and basically fraction knowledge. Because for me to get the probability that all have different signs, okay, I'm going to basically be taking 12 out of 12 times 11 out of 12 times 10 out of 12 times 9 out of 12 times 8 out of 12. I mean, the first one being 12 out of 12, I don't know which sign is it under. The probability of me having a person that has one of these signs, well, it's 12 out of 12. I mean, they have to. Now, for them to say it's different, the next person, the probability of that next person being chosen has a different sign is 11 out of 12. Because, there's still 12 zodiac signs. They're not exhausted. But now there's only 11 from which to choose from for that next person. So there's 11 out of 12 chance that that next person is going to have the same sign or have a sign different from the person before them. And then 10 out of 12 because the next person, there's now 2 of the signs have been picked, and it's all the way down the line. And if I do 1 minus that, I get about 0.6181. For part B, I'm going to let X be the number of people who are under the sign Aries. And I'm also going to make the contention here that under those kind of conditions, the probability of X being greater than or equal to 2 equals 1 minus the probability that X is less than or equal to 1, which means I'm looking for the 1 minus the probability of 0 plus the probability of 1. The reason why I'm doing that is, technically I'm looking for at least 2 of them being born under the sign of Aries. That means I have to do the probability of 2, the probability of 3, the probability of 4, the probability of 5. That'd be 4 probabilities I have to figure out if I did it that way. Whereas this one here, I really only need to figure out 2 probabilities. The probability of none of them being born under the sign of Aries, or just one of them being born under the sign of Aries. So that's 2 calculations compared to 4, so it's a little easier. Well, there's 11 zodiac signs that are not Aries. So the probability that I have someone who is not an Aries is going to be 11 out of 12. And so I would do 11 out of 12 times 11 out of 12 times 11 out of 12, so 5 times, and get 0.6472. The probability of having one person that's an Aries and 4 that are not is going to be, well, a lot of people think it's this. Just this by itself. Well, obviously that would be one person. It would be 1 out of 12. It would be a 1 out of 12 chance that person has the zodiac sign Aries. The next 4 people are each going to have 11 out of 12 chance of being one that doesn't have Aries. The problem is, if I look at it from that perspective, when I'm mapping it out this way, that's also considering the order in which they're being chosen. So for this one here, yes, if I was saying that, that this probability, if I just looked at that, is just the probability that the first person chosen is an Aries and the next 4 are not. That's not the that's not the only circumstance where I could possibly have, one person being an Aries and 4 people are not. It could be that the last person chosen is an Aries and the 4 that preceded him were not. It could be that the first 2 are Aries, or the first 2 are not Aries, the third one is, and the next 2 are not. So I have to think about, well, how many different possibilities, how many possible ways could I get one person that is an Aries and 4 people that are not? And there's 5 different ways for that to happen. That's 0.2942. So if I want to calculate the probability that someone was born under the sign of Aries, I'm going to do 1 minus the sum of those 2, which gives me 0.0586. So basically, if I have 5 people being chosen, the probability that at least 2 are under the sign of Aries is 0.0586, or about 5.86%.